Hi Huskies, this is Miss Dufour. Hope everyone is doing well. This is our day 3 of e-learning, and I know this is an adjustment for all, but we're making the best of it. Our objective today, we are looking at linear relationships, and specifically right now we are going to look at a table, and from the table write an equation that is represented by this table. Before we get started into digging into all these different strategies, I always kind of like to look at my table to see what I'm dealing with. One of the things I notice about my x values, and I like this in this problem because I notice that my x values are increasing by 1. That's a good thing. I also notice my y values, nothing really extraordinary stands out other than the fact that the y values are increasing, which tells me my line is going to be moving upward in this direction. Okay, so here are our strategies that we're going to follow, the same as they were yesterday. We're going to determine the form of the equation, determine the y value when x is 0. We're going to find the rate of change. We're going to write the equation, and then we're going to test the ordered pairs. Keep in mind that based on the information that we're given, we may not follow these in this order, and that's okay. Okay, so let's go ahead and get started. Can we determine the form of this equation? Well, to start with, look at what is the y value when x is 0. I'm giving when x is 0, y is not 0, y is 5/10. So I can, right off the bat, go ahead and scratch that out. So our equation is going to take on this form, y equal mx plus b. So I'm going to go ahead and write that down. So my next step, determine the y value when x is 0. That is going to be b in our equation. Okay, when x is 0, y is 5/10, so b is 5/10. So I've got part of my equation. That is our constant. Okay, next step is determine the rate of change. The rate of change will be m in the equation. And to determine the rate of change is the ratio comparing the change in y over the change in x. Now you can go back to our notes that are on the Google slide and you'll see the same information, okay, if you need to refer back to that. I'm going to start with a change in x first, and we've already talked about that. X is going up by 1 each time. So I know that number is 1. The change in y, so let's look at that. Y is increasing from 5/10 to 2. That's an increase of 1.5. From 2 to 3.5, again, that's an increase of 1.5. And the same increase from 3.5 to 5, again, is 1.5. So 1.5 over 1, which is just simply 1.5. That is our rate of change, or m. So go back to your equation. Y equals, we're going to substitute in 1.5. Right there. So the equation, I believe, if we've done everything correctly, y is equal to 1.5 plus 1/2, or 1 5/10 x plus 5/10. Now we're not finished because we need to test the ordered pairs. Often when you are assessed on this, you're given a multiple choice. So you're given a table with 4 different equations. At that point, a lot of times students will just skip right to this right here, and that's really not a bad strategy either. But we're going to test our ordered pairs by putting them back into the equation and see if this is what we get. So here we go. I know that when x is 0, y is going to be 5/10 because that's 0, so y equals 5/10, so that checks out. Okay, when x is 1, that's 1.5 times 1 plus another half. That's 1.5 plus another half. That is equal to 2. So my ordered pair is 1, 2, which is what we have here. I'm just going to keep going. When x is 2, 1/2 times 2, I'm sorry, 1.5 times 2 is 3. 3 plus 1/2 is equal to 3.5, or 3 5/10. So the ordered pair is 2 and 3.5, which is what we have here. It looks like it's working out. And the last one we're going to test is when x is 3. When x is 3, 3 times 1.5 is, what is that? Oh, I'm sorry, that would be 4.5. 4.5 plus 1/2 would give us 5. So the ordered pair 3, 5 works out. So our equation that we wrote initially is correct. Okay, so moving on to the next problem. This one is a little bit more rigorous. It's more challenging, and so you might have to watch this a couple of times. Okay, so here's our table, and one of the first things I notice in looking at it is that our x values are not going up by 1. And I also notice that we don't know what y is when x is 0. So those are two different challenges that we're going to have to overcome. At this point, I know which form it is, but you may not be able to know which form it is. So we're gonna skip down to determine the y value when x is 0. Well, we don't know that because I don't have the equation, plus it's not given in the table. So now we're going to move down to determining the rate of change. So remember, the rate of change is the change in x the change in y compared to the change in x. It's that ratio. So I can look at this. X is changing by, it's going up by 2 each time. And as x goes up by 2, y is going up by 2. That would be 6. From 8 to 14, that's 6. So x is going up by, well, excuse me, y is going up by 6. So our rate of change is equal to 3. Okay, so let's just look at the equation. If our rate of change is 3, we know that this part is true. We just don't know what b is. Is it 0 or is it another value? If it's 0, then we have a proportional relationship and it follows this, okay? I don't think it's going to be that just based on the information that we have here. One of the things I notice is you're going up by 2 each time right here. So what I could do is go back by 2. So instead of going up by 2 and going to 8, I'm going to go back here. If I subtract 2 from x, I get 0. Okay. Well, since I was adding 6 here each time, I would subtract 6 from 2. So 2 minus 6 is equal to -4. So when x is 0, y is -4. Okay. So this would give us, when x is 0, y is -4, that's going to give us b. b is equal to -4. So I can substitute that in right here. So here's the equation, 3x, y is equal to 3x plus -4, or subtraction means add the opposite. I can write that as 3x minus 4. Subtraction means add the opposite. This is most likely how you would see it when you're assessed. Y is equal to 3x minus 4. Okay, so I know which form it takes. I know the y value when x is 0. I know the rate of change is 3. I've written the equation. Lastly, I'm going to test the ordered pairs. So I'm going to take these ordered pairs and put them into this equation to see if it matches. When x is 0, y is equal to -4. So 0, -4 checks out. When x is 2, 3 times 2 is 6, and 6 minus 4 is 2. That gives me the ordered pair 2, +2. That checks out. when x is 4. 3 times 4 is 12, and 12 minus 4 is 8. So that gives me the order pair 4, 8. That checks out. Last one. 3 times 6, x is 6, is 18. 18 minus 4 is 14.